Hi everyone, this is another projectile problem, and in this one the original velocity instead of being up is actually down. So here goes. Zelda and Farley go on a date. They park on a cliff overlooking the ocean. Unfortunately, they are parked at an angle of 24 degrees below horizontal. Unfortunately, the brakes on Farley's car let go and they roll off the edge of the cliff. When they launch, the car is moving at 20 meters per second. So how far from the base of the cliff does the car land? And will Farley and Zelda ever go on another date? Okay, here's the situation. There is the cliff face here. And when this car rolls off the cliff, it is going at 20 meters per second. And it is at an angle of 24 degrees below horizontal. And the question is, how far do they go before the car hits the water? And I think I forgot a piece of information. I forgot a piece of information when I typed out the problem. The cliff is 30 meters high. So the question is, where, down here, where exactly does the car land? So we actually care about and want to find x, the horizontal displacement. First thing we do when we've got something at an angle like this is we break it into vertical and horizontal components. So let's do that. The horizontal velocity is the adjacent side, so this is going to be 20 meters per second times the cosine of 24 degrees. And the original vertical velocity is the opposite side, so 20 meters per second times the sine of 24 degrees. So let's pick up our calculators, put our numbers through here. For horizontal velocity, I got 18.3 meters per second. And for vertical velocity, I got 8.13 meters per second. Now, all of the motion is in the same direction. It is forward or down, so I can call all of these positive. Next thing you do is we're going to write down what we know for both sides of our situation. So on the horizontal side, I am looking for x. That's my big unknown. My horizontal velocity is 18.3 meters per second, and I do not know time. The other thing I know on the horizontal side is that the only equation I can use is the constant velocity equation because horizontal velocity is constant. One equation, two unknowns, so I have to look to the vertical side to find out more information. On this side, my original vertical velocity is a positive 8.13 meters per second down. I don't know time. I do know acceleration of gravity because gravity is going to speed it up at 9.8 meters per second. And I do not, I do know 30 meters. My vertical displacement is 30 meters. So here's what I'm going to do. I need to find time on this side so then I can turn it around and use that time over here because when it hits the ground, it's going to hit the ground. Now, I do not have directly an equation that has VOT, A, and Y in it without having to use the quadratic. And so because of that, and you certainly could use the quadratic equation, it's a sweetie pie and it's very handy, but instead I'm going to do a two-step approach. First, I'm going to find final velocity, and once I have final velocity, time is going to be easy to acquire. So I'm going to use original, gravity, and y to find final, and that's going to be VF squared is VO squared plus 2AY, the vertical displacement. And I'm looking for final velocity, so the square root of my original, which is 8.13 meters per second, quantity squared, plus 2 times 9.8 times y, that 30-meter height of the cliff. When I throw all that in my calculator, I get a final vertical velocity of 25.6 meters per second. Now that I have that, time is easy to acquire, so I'm going to find time, and I'm going to use final velocity is original plus AT, so time is going to be equal to final minus original divided by rate of acceleration, and my final velocity was 25.6 meters per second, minus my original, which was a positive 8.13 meters per second, divided by gravity, and because all the motion is in one direction, I'm going to keep everything positive, so 9.8 meters per second squared. So the time that they are going as they are falling off that cliff into the water, I calculate that as 1.78 seconds. Now that I've got time, I'm going to turn around and take that 1.78 seconds, take it back over here, 1.78 seconds, and I can find the horizontal displacement, which is how far from the cliff they're going to land, and that's going to be 18.3 meters per second times my time of 1.78 seconds, and that gives me a displacement of 32.6 meters is the distance. 32.6 meters is that horizontal displacement of where the car is going to land. Now, are Farley and Zelda ever going to go on a date? Oh, I bet so, because love is a wonderful thing. All right, we will see you next time. Bye-bye.